Hey everyone, welcome to our final week discussing the book Calling Bullshit. We're going to go ahead and jump right in with a discussion of conditional probability. So you can think of probability as how likely something is to happen. It's slightly oversimplified, but if I flip a coin, there's a 50% chance it's heads, 50% chance it's tails. Conditional probability is how likely something is to happen given some other event has already occurred. So if I flip a coin and then I flip it another time, well, actually, it's still 50-50, right? In this case, those two events are independent. Conditional probability doesn't come into play. It doesn't matter. There is a famous fallacy called the gambler's hot hand, which suggests that it does. Like if I flip a coin heads 5 times in a row, the next one is more likely to be tails. That is false, assuming the coin is fair. The only reason it would be more likely, if it was more likely to be something, it would be more likely to be heads, and that would be because perhaps I had a two-headed coin, right? Maybe not after 5, but at some point, like if someone flips 20 heads in a row, you should probably assume that the coin is like not a fair coin. However, slight digression into questioning the assumptions behind your model of whether it's a fair coin or not. Conditional probability is we have some event, let's say a person carries an umbrella. It's more likely to happen when it's raining. So like you can see, and in this case there's a clear like cause and effect relationship. The probability of someone having an umbrella with them is higher if it's raining, or even if the weather forecast called for rain, right? And we can see that there is an actual change in behavior, and we can actually quantify that. Okay, so part of the reason we need to talk about conditional probability is because the book gets into p-values, which cause a lot of problems in research, to be quite honest. And I'm going to jump to the middle of the slide here. P-values tell you the probability of observing data conditioned on a hypothesis. And that's a weird thing to tell you. Like just if you're not a statistician, you almost always want to know how likely is my hypothesis given the data that I've observed. And it gets even worse because p-values are telling you the probability of a set of data conditioned on the null hypothesis. Usually, you can set it up differently. But generally speaking, they're not even telling you the probability of a set of data given that your hypothesis is correct. Most of the time, they're giving you the probability of a set of data given that there's no actual effect. So you hypothesize there's some effect, and this tells you the probability of seeing data if there weren't any effect. It's kind of weird. So the best way I have to sort of make sense of what's going on here is to think within the logical framework of proof by contradiction. So traditional logic holds if A is true, then B is not true. Let's take that as a given statement. Then B is true, therefore A cannot be true. Reason that out. If A were true, B would have to be true. We know B would have to be not true. Apologies. If A was true, B would have to be not true. We know B is true, therefore we have a contradiction. That contradiction tells us that premise that we tried to initiate, A being true, is a contradiction. So A must not be true. In the statistical logic, instead of true and false, says for the hypothesis if H is true, then our observed data is highly unlikely. If we actually observe that data, H is unlikely to be true. We can reject the null hypothesis. I'll note that we can't ever accept the alternative hypothesis, which is usually what we're interested in. So again, this is a somewhat frustrating state of affairs. We've just rejected the idea that there's no difference between two groups. And sometimes this makes a ton of sense. So taking some examples from when I used to work in the bourbon industry, if we're testing 2 different barrel designs for distilling whiskey, or for aging whiskey if it's barrel designs, it makes sense to start by assuming they offer the same yield. If we observe data where that's not true, then it's probably reasonable in a practical sense to conclude that one barrel is better than the other, that they're not the same. We've rejected the idea that they're the same. If we're trying to find the price elasticity of whiskey, though, it doesn't actually make sense to start by assuming that two different prices result in the same number of sales, and whiskey and like price has nothing to do with sales. If you find that, you probably just don't have enough data. Because again, it's just like very unlikely that a commodity is going to be completely price inelastic, where the price makes absolutely no difference to the number of sales you have. Okay, that was my quick overview of p-values. I'd love to talk longer about it, but unfortunately this is not a class in policy analysis. It's a class in policy process. I shouldn't say unfortunately. Both are really interesting, but unfortunately we can't be a class in both. So we have to choose one. It's policy process. We talk about spotting bullshit here, and just to sort of recap what's in the book, and I'm just going to go quickly because here I do assume that the reading's been done. Always question the source of your information. Be aware of any unfair comparisons. If it seems too good or bad to be true, it probably is. Think in orders of magnitude as a quick way to sort of gut check the information. If something is in the wrong order of magnitude, that might be a quick way to spot that it's not true. Avoid confirmation bias. If something seems too good to be true, it probably is. If it's something you've long believed, that doesn't mean it's true. And that's the case where you should perhaps do a little extra work to make sure that you don't just approve of this because it fits with something you already want to be true. And consider multiple hypotheses. Think about, multiple ways to interpret the information that you're being given. And then they also offer some examples of how to refute bullshit. They suggest to use reductio ad absurdum. While this is logically effective, I'm not completely sure it's going to be public opinion effective. Being memorable, on the other hand, definitely tends to help. Counterexamples are a really strong debate tactic in general. This is probably going to be, where applicable, one of the strongest ways you can provide a counter, like just give a clean counterexample. Analogies, very helpful for explaining things. Redrawing any figures that are wrong. We talked about data viz and some of the ways that it can be manipulated. And then here, just like make a very simple model is what we're talking about with a null model. And sort of actually going through the mechanics of making a model can just be helpful with the thought process. The idea is not that this is like a true model of reality, but that it's a tool to help you think. Okay, that's it on this book, and I will look forward to our continued discussion.